Welcome back to my maths homework. I think this time the homework is a little too lengthy. It's just going on. Okay, fine. So here are some more questions. The first one is 1 cube plus 3 cube plus 5 cube plus 7 cubed keeps on going till n terms. So we have to find what that sum is. Fine. So what's the general term of each of these terms? Yes. So the general term is going to be 1 plus 2n, right? I mean 2r I should say, because now, okay, fine, it's like 2r raised to the third power, right? So that's the general term. Now we are summing this thing from r equals to 1. No, wait, r equals to 0, so maybe I should put 2r minus 1. That will be much better. 2r minus 1 from r equals to 1 to n, right? So this thing is the same as saying summing up from r equals to 1 to n of, just going to expand this thing, this cube. This can be written as 8r cubed minus 3 times, okay, this thing squared. So for 12, yes, it's like 4 into 3 is 12, so 12r squared plus, what's this thing, 2r into 3, that's supposed to be equal to 6r, okay, minus 1. Okay, fine. So this thing is going to be 8 times, okay, so like r cubed, the summation of r cubed from 1 to n, that is just n squared into n plus 1 squared upon 4. So this cancels, you got 4 over there, minus 12 times the summation of r squared. It's like, you know that 6 is going to get cancelled, so just going to write it like that. 2 times n into n plus 1 into 2n plus 1, then plus 3 times n into n plus 1 minus n. First of all, just take some stuff common. First of all, I can take n common from this, n into 8n into n plus 1 squared minus, you got 2 into n plus 1 into 2n plus 1, okay, and then plus 3 into n plus 1 and minus 1. Fine. So it's going to be n, wait, this is supposed to be 8n into n plus 1 squared, right? So what can we do now? First of all, we can take n plus 1 common from each of them, actually from this one as well. So like n plus 1 into, you got 8n into n plus 1, that will be 8n squared plus 8n. Then you got minus, this thing is gone, so minus 2 into 2n plus 1 is minus 4n minus 2 plus 3, then minus 1, supposed to be equal to n into, we got n plus 1, it's like 8n squared plus 4n, this is just 1. Fine. So n plus 1 into 8n squared plus 4n plus 1, okay, it's supposed to be equal to 8n cubed plus 4n squared plus n plus 1, so that has to be plus 8n squared plus 4n plus 1, and then you got minus 1 over there, so this cancels. It's going to be equal to n squared times, what's this thing, actually I should not hurry. So you got okay, 8n cubed plus 12n squared plus 5n. Wow, that's some calculations. You got n squared into 8n squared plus 12n plus 5. Now I won't be factorizing this. Fine. So yeah, that's the first question. Let's go to the next question. So the next question is 2 cubed plus 4 cubed plus 3, okay, plus 6 cubed plus 8 cubed, keeps going like that. We have to find n terms. So the general term is just 2n cubed, right? So if we sum, I mean 2r cubed, so if we sum this from r equals to 1 to n, you can just take that 8 common, so you will have r cubed from 1 to n. Yes, that's just going to be n squared into n plus 1 squared upon 4. So it's just 2n squared into n plus 1 squared, like that. Easy. Okay, the next thing is, okay, 1 into 2 into 5 plus 2 into 3 into 6 plus 3 into 4 into 7. Okay, fine. So 5 6 7 difference is 1, 2 3 4 is also like difference is 1. Fine. So this thing is r into r plus 1 into r plus, I think r plus 4, right? Yes, that's the general term of this thing. So like summation of this thing from r equals to 1 to n shouldn't be too hard. Like r equals to 1 to n of, what's this thing, r squared plus 5r plus 4. So r cubed plus 5r squared plus 4r. Okay, so r cubed, that's going to be n squared into n plus 1 squared upon 4 plus 5r squared is like 5n into n plus 1 into 2n plus 1 upon 6 plus 4r, that's supposed to be 4 into n plus 1 upon 2. Okay, let's take some things common. So you got n into n plus 1 upon 12 common, right? So the remaining stuff is like 3n into n plus 1, and then plus you got 2, so 10 into 2n plus 1, and then this thing is gone, but you got upon 12, so you have to multiply by 6, so it's supposed to be equal to 24, I think. So that's going to be n into n plus 1 upon 12 into, so what's this thing? You got 3n squared plus 3n plus 20n plus 20 plus 24. All right, fine. So what's this? You got 23n, so like 3n squared plus 23n plus 44, right? And that thing times this thing's like n into n plus 1 upon 12, right? Just tedious and not very useful. Yeah. The next question is 1 plus, we have done this question once. I'm not doing it again. 1 into 2 plus 2 into 3 into 3. Oh, we have done that also once again. I'm not doing this. Okay, so 3 into 1 squared plus 5 into 2 squared plus 7 into 3 squared keeps going like that. Looks interesting. Let's just do this. So 3 into 1 squared plus 5 into 2 squared. You can see that these are the values of r itself. So you have r squared times r plus 2. Oh, that's it. No, wait, actually 2r, fine, it's like 2r plus 1 maybe, right? If you put r equals to 1 in this, you get 3. For r equals to 2, you get 5 and stuff. Fine, so if we sum this up from r equals to 1 to n, it's the same as summing up 2r cubed plus r from 1 to n. So just get 2. For r cubed, you just have like n squared into n plus 1 squared upon 4. Upon 4 is like upon 2, fine. Plus r, so you have n into n plus 1 upon 2. That's going to be n into n plus 1 upon 2 into n plus 1 plus 1 is supposed to be equal to n squared plus n plus 1. That's nice. It was a little more interesting. Fine. So next question is find the sum of the series whose nth term is 2n cubed plus 3n squared minus 1. Fine. So sum of the series whose nth term is this thing, right? So if its nth term is this thing, its rth term, so its rth term is supposed to be 2r cubed plus 3r squared minus 1 as well. Fine. And we have to find the sum of this series. Well, till how many terms? We don't know. We don't know till how many terms we have to do that. So I'm just going to assume that we have to do this till capital N terms. Okay, instead of using r, we'll just use small n itself. So it's from n equals to 1 to capital N of 2n cubed plus 3n squared minus 1. Well, first of all, n cubed, that's supposed to be equal to 2 into n squared into n plus 1 squared upon 4, and then you got 3n squared, it's supposed to be 3n into n plus 1 into 2n plus 1 upon 6. I'm not going to simplify this further because I'm just tired from doing all that stuff. Okay, so whatever that simplifies to, that will be your answer. Okay, so the next thing is, okay, this thing, n cubed minus 3 to the nth power. Fine, not a big deal at all. So like n cubed, what's that supposed to be? N into n plus 1 squared, I mean both of them squared basically, upon 4 minus 3 to the n power. That's supposed to be equal to, you have minus 3 minus 9 minus 27, keeps going like that till you have minus 3 to the nth power, right? Something like that, capital nth power, something like that. So yes, I think so. What's that supposed to be? That's supposed to be minus 3 into, the ratio is 3, so you got 3, and the number of terms is capital N, obviously. So 3 to the n minus 1 upon 3 minus 1 is 2, so minus 3 by 2 of this thing. Yeah, it's going to leave it like that. Okay, so next thing is n into n plus 1 into n plus 4. Okay, that's nice. Just actually not nice. It's going to be a third degree expression. Oh, come on. So it's going to be n cubed plus what? Got 5n's, like 5n squared plus 4n, and we sum this from n equals to 1 to capital N, just like that. So yeah, I don't want to do this now, but just have to. So yes, n cubed, that's supposed to be n into n plus 1, both of them squared, upon 4 plus 5. You know what, you can do this on your own. I'm not doing this. Okay, the next thing is 2n minus 1 squared. Okay, it's the same thing. Just have 4n squared minus 4n plus 1, and you're summing the sum from n equals to 1 to capital N. Just use your formulas, get this done. I'm tired of doing it. Okay, find the 20th term and the sum of 20 terms of the series 2 into 4 plus 4 into 6 plus 6 into 8 keeps on going. Okay, so we have to find the 20th term and the sum of the 20 terms. Yeah, so let's find the general term of this thing. So you got 2 into 4 plus 4 into 6 plus 6 into 8, 4 6 8, these are in arithmetic progression. 2 4 6, these are also in arithmetic progression. Okay, that's nice. So this can be done as you got 2 4 6 8. It's just 2 times 2 times r, right? Times you got 4 6, okay, 4 6 8 stuff. This is just 2r plus 2. Okay, and we okay, that's supposed to be our rth term, right? So what's the 20th term in that case? So t20 is supposed to be t20. Fine. So 2 into 20, that is 4, sorry, 40 into it's like 40 plus 2 is 42. Fine. 168 is like 1680. Yes, so not a big deal at all. Now we have to find the sum of the first 20 terms of this series. Okay, not a big deal. So if we sum this from r equals to 1 to n, all right, then what we get is, okay, first of all you can just factor out a 2. So you get 4 times the summation from r equals to 1 to n of, what's this thing, r squared plus, why does this, okay, this keeps on coming so often. Fine, maybe we should just memorize what the result of this sum is supposed to be. Fine, so it's just supposed to be, what's this thing, you got r, it's like n into n plus 1 into 2n plus 1, it's like r squared, that gives me this thing, upon 6 plus n into n plus 1 upon 2. Okay, fine, so it's supposed to be 4 by, just take a 12 common, so, and also n into n plus 1 common. So you got 2n plus 1 plus plus what, plus what's this thing, so you got 3 over there, so 2n plus 4, it's supposed to be equal to 2 upon 6, or I should say 1 upon 3. So this is just 2 upon 3 of n into n plus 1 into n plus 2, like that. Easy. That's it. So yeah, hope you enjoyed it. Fine. I'm erasing all this stuff. I'll see you in the next video.